right, so we are going to run a linear regression t-test based on this data about high-stakes testing. So I don't know if you guys saw in the little blurb here, right? But a psychologist interviewed the students before taking the test, all right? And they were assessed a level score from 1 to 10 for the anxiety. I assume 10 being extremely anxious. And then they have a score. It doesn't say what the scores are out of, but the highest one I see is a 100. So I'm going to go with it's out of 100. All right, so what do we think? Do we think anxiety level explains their test score, or do you think their test score explains their anxiety level? That's what I would go with. So that means if I'm going to graph a scatter plot, which I'm going to here in a moment, all right, I'm going to put, right, on the x-axis my anxiety level, right, and on the y-axis I'm going to put the test score. So that thinking, that phrasing is what we did in the first semester. So hopefully you're good with that. One thing before we get started, just in case you forgot and you want to do this before the AP exam, do you guys remember what you need to do to make sure that if you do run linear regression, that you get the letter R, the correlation coefficient? Do you remember what you have to go to in your calculator? So if you go and hit second 0, which is catalog, do you remember doing this? Somebody remembered. Who said that? D? Yes, down to D. Diagnostic on. It's fun, right? You're good. A little A plus BI, complex numbers there. Gosh, good times. Chi-squared. Now you know what that means. Cosine. Yay.
What was that thing where we just did?
Yeah, I forgot.
Yeah.
I'm already there. All right. Diagnostic on. Hit enter. And then don't forget to hit enter again. All right. So if you don't do that, you will run your linear regression and be like, wait, where is the letter R? That's how you got to get it. All right. Okay. Look at that. A little AP exam review, Leslie. See, you're good to go. All right. So after we put it in the calculator, this is what we're going to do. All right. We want to see if there is enough of a linear relationship between these two quantitative variables to see if we are going to say that, in fact, yes, there is that relationship between them. All right, so you see the null hypothesis. You can do words or symbols. All right, so I've got both there, your choice. You can write the sentence, or you can use the symbols. That symbol is a capital B beta, all right? And this would be, if you see that little blurb at the bottom, is the slope if we essentially had all of our values in the population, right? And then we found the slope of the regression line. We won't know what beta is, but you can see in the null hypothesis, we assume it's 0. Do you guys remember about lines that have 0 slope? You guys remember something about lines with 0 slope? They're horizontal lines. Yes. So we're essentially assuming that it does not have a linear relationship, so the slope would be 0. All right, we're trying to prove that that's, in fact, not true, that there is a linear relationship between these two quantitative variables. I'm trying to stress that a lot today, right? These are two quantitative variables. So on the AP exam, you know, the odds of you getting a free response question to run this test are low. But just in case, if you're trying to find the linear association between two quantitative variables, that would be this test. Remember, the sentence or the symbols are just fine for the hypotheses. You don't need to do both. Any questions so far? There's our last one. So after we take this test and we start reviewing, when we get to the inference part of the review, we're going to figure out, okay, how do we figure out which test to run if we have all of them we're looking at? Yes, it was.
So do we need to say linear association?
I put linear association just to show you that I'm talking about the that these are quantitative variables, but I don't think they'll count off if you put association. All right, so the first assumption, or at least condition here, is we need to make sure it's quantitative. I want to stress that a lot. If you're doing this, if you're like, wait, are these actually quantitative variables? If they're not, you should not be doing this. All right, so you're thinking about, can I think of the units that are going along with these? All right, if you're counting like categories, then maybe this is chi-squared. All right. Now we're also going to assume that there is a linear association between the two variables. All right, so what do we need to do there? We need to check the scatter plot. All right, so I know you guys are writing, but pause for a second while you're writing. I'll go back and take out your calculator so we can make the scatter plot. You guys remember where to go to make the scatter plot? Second stat plot. I'm going to just turn the first one on. So second stat plot, turn the first one on. Do you remember which one is the scatter plot? It's actually the first one. You know we've been spending a ton of time on the third one, right, with the histogram, right, but we're back to the first one. All right? Now, what did we say was our sentence for describing these two variables? Explains the mass score. So the reason I use that word explain is that way you think anxiety is the explanatory variable, which is the X variable. So you can see where the X is. I have list 1, which is my anxiety level, and my Y, my response variable, is the math test score. Okay, so that should be good to go. Eduardo, if you have it in list 2 and 3, make sure you update those. Yeah. List 2 and 3. Okay. All right, so hit graph. I don't see anything. Zoom 9. All right. Oh my gosh, it's been forever. What 3 things or 3 words am I thinking about when I describe the association in a scatter plot? Oh my God. Strength? Okay. I always say direction, form, strength, but I don't care the order, Thomas. Direction, form, and strength, right? Direction, form, strength. So what direction? There is a negative. Form, guys, remember, you're trying to, like, the bar's low here. We're trying to say what word? We're trying to say linear, right? We're trying to say linear. So do we think that's linear? Yeah. Yes. All right. Yes. Say yes, right? Just say yes to the scatter plot. And then what about the strength? Weak. Weak to moderate. Don't say weak to moderate. Pick one. Okay. I'm going to say moderate, but weak is fine. Definitely, I think we would all agree, not strong. What would make this look strong? Super tight, very less scatter, right? Super tight, less scatter is strong. Now again, if you say weak, if you say moderate, what can you check to see if you want to change your answer? Find R, find the correlation coefficient. That is literally the measure of the strength of the linear relationship, okay? I think you'll see R is approximately 0.5, so, or negative 0.5. So we're going to say moderate here, okay? All right, so we checked the scatter plot. We're going to go with linear. Okay. Oh, wait, I'm sorry. I said I would go back. Go ahead and finish now. Okay. Now, I know it's been a long time since we did chapter 10, but if you want to do all this and you say it's not linear, like Luis over here was shaking his head, you're saying it was not linear, right? This is why I think the bar should be super low to clear that hurdle of linear. If you don't think it's linear, you have to re-express the data. Do you remember doing that? No, remember the ladder of powers? Where we took the y values, first we squared them, then we did the square root of them, then we tried 1 over the y values, then we tried the logarithm. Yeah, do you really want to do that? No, you don't want to. Exactly, Eduardo, you coming around, right? Oh yeah, now it's linear. And again, if you do get a re-expression question on the AP exam, I cannot guarantee it, but my go-to in high school was always the log. Try the log of y first, then try the log of both. Right? They love using logarithms because they know students don't like them.
Wait, I have a question.
Yeah.
For questions like these, so would it be wrong to say it is linear and go through the process? It just wouldn't be favorable because it has a longer process. Is that what you're trying to say?
I'm trying to say that when they're doing this, the odds of them having you, first off, they're not going to make you do any of this. If they're going to make you do a linear regression t-test, they're going to have everything already there for you because it's a lot of button pushing. My thought is if the AP exam is going to ask you to do this, they don't want you to do all of that, right? They're trying to be cognizant of time, right? And doing re-expression within this is asking a lot. So they might ask you a question about re-expression, usually in the multiple choice. They'll say, like, based on this, would you re-express? And, like, how would you re-express it? That kind of stuff, right? Don't worry. You'll see some on, if you take the test Wednesday, April 5th. Good times. Okay, are we good on checking the scatter plot? It's been a while since we've done that, right? Now, the next thing I want to say is that the students that are a part of this, right, our sample, they're independent of one another. So what would make me worry about that? Anything would make you worry, or no worries? No worries. Okay, we're good. I'm good with it. We're trying to think if there's anything that would cause you to worry about independence, right? I mean, I think maybe family members, right, in terms of anxiety levels. I'm not saying it's passed down or anything like that, but maybe if they're living in the same home environment, having those same conditions, that could influence their anxiety. You'll notice it doesn't say random, so I'm saying that the individuals are a good representation of the population. Now, like we did in chapter 8, if you say that when you look at the scatter plot, it is a linear relationship, what should we check next in terms of, is it appropriate to go forward with a linear model? We're going to check the residuals plot. So let's do the linear regression, because you got to do the linear regression first to get the residuals. So I'm going to come back. Don't worry. Just pause what you're doing. All right. You guys remember how to do the linear regression model? Yes? No? It's stat. Calculate. And do you remember which one that we focused on for linear regression? Actually, not 4. I did 8. But 4 is fine. There's nothing wrong with 4. I'm just going to do a plus bx. But if you did 4, that's fine. Just make sure you get the right slope and y-intercept. Now, again, if you hit this, right? If you hit this and you haven't done diagnostic on, will you get all the information? No. So make sure you go to second 0. That's the catalog. All right, to do diagnostic on. If you're listening, you're like, I didn't get it. All right, do that first. All right, I think we're all good on this. If you want to store it, it's been a long time since we've done this, but you can hit vars here, hit vars. If you want to store, you don't have to. Vars, and then y variables, and then go to function, and you could store it in any of those if you wanted. You don't need to, we're not going to use it, but if you wanted to, that's how you do it, how you store it, if you want to store this. So I'll click that, but I really don't care. Okay, hit calculate. All right. So again, I think, Thomas, you said weak. You'll notice the R here is approximately, roughly negative 0.5. So that to me is moderate. All right. I would need to get further away from, or I guess closer to 0 to get into the weak category. All right. So if you want to write down this, you can. I have it on the later slides, so I don't need to. But again, what you would write down, what was our Y variable? The test score. And what do I put on top of it? It's been a while. What do I put on? Yeah, what else do I have? All right. Equals. All right. Then I'm going to put the y-intercept of 91.658. And you can round. I don't care about the rounding here. Minus 4.486 times your anxiety level. It has been a long time. All right, hopefully you remember all those questions of describe the slope in the context of this situation for each additional unit of anxiety. If I bump up from an anxious level of 4 to 5, what should I expect to happen to my math test score? Go down by approximately 4.5 points. That's what the slope means, right? What does this mean? What's my y-intercept mean in this context? Initial. Without any anxiety? Yes. So an anxiety of 0, I'm expecting to score 91.608. Now that doesn't really make sense because can you get an anxiety score of 0? No, right? It was only 1 to 10. So that really doesn't make sense at all. Okay. So just anyway, been a while, but that's stuff we did in the first semester. Okay, you guys ready for the residuals? All right. So go back to your stat plot. So second stat plot. I'm going to go to the first one. Second stat plot. Go to the first one. All right. Do you guys see where it says the Y list? Right? I want to change that to be residuals. It's been a while, But again, if you haven't run the regression, right? If you haven't done the linear regression, you can't do this. It won't have an option to do this. So hit second stat. So second stat, which is list. Second stat, which is list. And you guys, hopefully you see number 7. Here it says resid. Again, if you don't see that, what does that mean? If you don't see resid, you haven't done the regression first. You got to do the linear regression first. The computer has to find the residuals first. Okay? All right. So hit resid. Then hit graph again. Zoom 9. Oh, I should have taken that off. I'm sorry. Let me do that. I do that every time. If you want to get that off, go to y equals, over to the equal sign, hit enter, and it will not graph it. Sorry about that. It's okay if it's there. Zoom 9. What are we hoping to see in the residuals? A cloud. What do you think? Sure looks like a cloud. Remember, guys, low bar here, right? Low bar. Right? Doesn't look like a very distinctive pattern. So in terms of using this model, whether it's good or not, right? Whether I like it or not, it's appropriate. That's the key phrase. It is appropriate to use this model. Yes. Gosh, you guys are going to crush this AP exam. Okay. Another condition we need to check is to make sure that the spread of the residuals is uniform. So what we're going to do is we're going to make a histogram of just the residuals. I know, exciting. We're going to make a histogram of just the residuals plot. Okay? I'll give you a moment to copy that down.
How do you get the line for residuals?
Well, how to do the residuals? So hit second, y equals, and then hit enter, and then go down to list 2, and then hit second stat, which is list, and then go down to resid. Hit that, and then hit graph. Up there, graph. And hit zoom 9. There you go. You got it. Residuals. Yay. Okay, so let's make a histogram of just the residuals. Hopefully we'll feel good about histograms. Second stat plot. I'm just going to keep using the first one. All right, go over to histogram. All right, you see where it says list 1? All right, I want to change that to be residuals. So second stat down to number 7.
Are we changing the first plot graph?
I'm always changing the first one because I don't want to have to deal with like turning one off, turning one on. But it's up to you. You can do multiple. Whoa. Zoom 9. What do you think? Again, guys, low bar. Is this unimodal and roughly symmetric? Second stat will get you list, which will give you that. Yes, what do we get? Do we think this is unimodal, roughly symmetric? Remember, low bar, super low bar.
Yeah.
Yeah, it looks good. No issues there. All right, let's go to the next thing. All right, so we just did that, the histogram. Now, the last thing I'm going to check for are any outliers. Now, you could do the math, right? You could do the math. You could find, I don't know if you guys remember how to do outliers. You guys remember how to find outliers? What do you need to find an outlier? Yeah, what are those called? No. Yeah, we're going to find those. We need to do a lot more stuff before we can find the fences. Oh, gosh. So we got the median, right? Somebody said it. Was that you, Diana? Nice. We got the median, which is the middle of the data. If we find the middle of the first half of data and the second half of the data, Diana's right, we need the quartiles. All right, so that's quartile 1 and quartile 3. Once you have those, then what can you find? What's the difference between those two called? Nice, right? The IQR. Oh my gosh, next week's going to be awesome. Right? Which is Q3 minus Q1. And then in my class, which may be different than what your professor does if you take stats in college, I use 1.5 times the IQR. And then I use that to find the fences. Right? The lower fence is going to be quartile 1 minus that value. And the upper fence is going to be quartile 3 plus that value. Now, am I going to do this by hand? No, that seems extremely cumbersome. Do you know what's a much faster way to do it in the calculator? You can make a box plot. If you make a box plot, it will actually show you a symbol for any outliers. So that's why you'll see I make a box plot. You don't have to. You can do this all by hand. All right, and again, we'll practice this in our review. So I'm going to make a box plot. Yes, Thomas, I'm using the same stat plot, the first one. All right. The box plot is, there's two options. You guys see the two options here? Choose the one that has the little dots. Do you see this one that has a few little dots after? That tells you that it will show you outliers. If you choose the one that doesn't have the little dots, the fifth one, right, the next one there, it won't show you outliers. All right, so choose that one that has the little dots. I don't want to use residual anymore. So I'm going to do second stat list. And I want to get that to be list 1. Let's graph that. Don't forget zoom 9. Do you guys see any little dots past my min and max? No. Do you see any little dots? No. So are there any outliers for the anxiety level? No. Let's do the same thing for list 2. I know I'm going fast. Any dots for list 2? For the test score? No. So no outliers. But you got to check to make sure there are outliers. So I put in these 2 slides here to summarize what we're going to do. All right, we work kind of in this order. All right, so you got to make the scatter plot, make sure it shows a linear relationship. As I mentioned, if it's not linear and you want to do all this, you've got to re-express some data. Then you're going to make your regression model to check the residuals. Then go from there to make a histogram of the residuals, and then make sure there are no outliers. And after that, you are ready to run the test. So you'll notice we've got 2 variables here. So to find the degrees of freedom, we do the sample size minus 2, since we have 2 of those variables to factor in. I don't want you to be nervous by this, guys. I know this is a lot. Really, I wanted to take all this time to kind of review all the buttons and how to find that stuff from the first semester. As I said, on the AP exam, if they ask you to do this, they're not going to make you do any of that stuff. You can also write down here too if you want. Any questions so far on this process? I know it's been a lot. We're almost finished. Now, you'll notice when we move forward, we're ready to actually do the mechanics, but there are no mechanics to run. I'm not going to show you any work to do here. I will show you how to find the t-test statistic and the p-value using the calculator. But again, like I said, they're going to give you computer output. So there's a slide later on that shows you that computer output, so I'm going to focus on pulling the stuff from there. All right, I can always come back to if you're not finished. No worries there. Okay, so now we're ready to look at the mechanics. Here's that computer output. Do you guys want to see how to do it in your calculator? Let's do it in the calculator, and then you'll see that we got the same stuff. So hit stat, go over to tests. I'm going to scroll way down here. Do you remember what test we're calling this? It's actually this linear regression t-test. It is letter F. Nice. Linear regression t-test, letter F. If you want to do an interval, that's letter G. All right, I think we're good on list 1, list 2. In my experience of high school, they've always just done not equal to, so I'm not going to change that. Again, here's another opportunity to store the regression equation if you wanted to. I'm not going to. So I'm just going to hit calculate. So our test statistic is negative 2.893 with our p-value of 0.008. The moment I read 0.008, what am I thinking about that p-value? That's actually pretty small, right? That's really pretty small. It's usually smaller than any alpha you might choose. I just want to point out one thing. You'll notice if I scroll down, what did it also give me? It also gave me, I guess one too far. It also gave me the linear regression pieces or components, right? There's my y-intercept, there's my slope, and here is my R, my correlation coefficient. So all that stuff that we already had, right, gives it to you again. Okay? All right, now let's go to this. This is the most important part of how to find this stuff. All right, we already talked about the model here. All right? You guys would have seen this in the first semester. I showed you a couple of computer outputs like this. All right? The key thing I always go to is the one that doesn't say constant or intercept. So this one, it says constant, or you're looking for intercept. That obviously is the y-intercept. I go to the other one. This is the one I care about. If I go all the way across, you see where it says t ratio here? What is this? This is the t-test statistic. And what is this prob over here? The p-value. So just be careful, right? That's how they're going to try to get you messed up. Got to go to the one that doesn't say intercept or constant. Okay, that's where I care about the t-test statistic and the p-value. All right? Everybody else okay? All right, so I think we're ready for, you can draw a sketch and the mechanics one if you just want to draw a little quick T model here. You'll notice this is two-tailed. It's kind of hard to see, but if you look, there's a little bit of shading going on, the left tail and the right tail. I know it's really small, Australia, because, hey, the p-value is small. Don't forget to put your test statistic. So t equals negative 2.89 and your p-value of 0.0085. Now let's try to do the conclusion, right? What did we assume at the beginning about these two variables? That there's no linear association. So if we're throwing that out and going with the alternative, what's the alternative hypothesis? That there is a linear association. So you'll notice in my conclusion, I'm going to go with the alternative that there is a linear association between these two quantitative variables. All right, so we are saying, right, if your anxiety increases, we expect your test score to go down, or the vice versa. If your anxiety decreases, we expect your test score to go up.